He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
They say life is stranger than fiction.
So you could be weaving this thread of gold, but as thin as it is, it's probably falling apart all over the place. I wouldn't weave cloth out of gold, partly because it's not a very strong thread and partly because it would be incredibly heavy.
But sometimes what we see in movies or read in books is so incredible that it obviously couldn't be possible. Or could it?
If we took that hay bale and turned it into gold, that metre-long bale of hay would shrink to something that was only 20 centimetres long. It's very dense.
Welcome to Sci-Fi Sci-Fact with me, Brian Grimm. Every week a scientist from New Zealand's MacDiarmid Institute explains the facts behind the fiction. There's science in fairy tales as well, and in this whimsical episode, MacDiarmid Institute Principal Investigator and Professor of Chemistry at Auckland University, Duncan McGillivray, tries to work out how Rumpelstiltskin made straw into gold before he lost his temper.
Spin straw into gold, eh? What will you give me if I spin the straw into gold for you? The girl offered him her pearl necklace.
It is very precious to me. You may have it.
Done! Cried the little man, and he jumped to the spinning wheel. Whir, whir. Right before the astonished girl's eyes, the straw was turned into bright gold coins. As the strange little fellow worked, he sang a song to the rhythm of the spinning wheel. The spinning wheel goes round and round, it hums and sings its spinning sound. My secret never will be told, I'll spin the wheat straw into gold.
Duncan, I'll try and ease you through this. I mean, it's Rumpelstiltskin. We can't go wrong with that, can we?
No, it's fascinating. Actually, it's even more fascinating than I thought it was when I started. So.
Yeah, well, there's a lot of elements. I had to go back and remind myself of the story. So you've got this miller who says, "Hey, I'm a big deal, and I can I don't know what does he tell the king he can do? I can make
his daughter. He says, my daughter's the most amazing person. She can spin straw into gold.
Yes. And then the poor daughter ends up having to do this for the king, and that's when Rumpelstiltskin arrives and says, well, I'll do it for you. But then the price every time gets higher and higher until it's the firstborn child of the daughter. And at this point it's getting pretty heavy. And then there's the deal about guessing his name and three attempts to guess his name. Now, of all that stuff, what's the bit that you're most interested in as a scientist?
Well, I mean, to be honest, it's all fascinating, and there's real science in figuring out how old this is. There's science in understanding why we care, and there's science. But the bit that tweaked my interest was, straw to gold, transmutation of the elements, bit of alchemy, really. How much is that possible? There's a lot to unpack in there.
Straw is mostly carbon, I'm guessing.
Yep. So, if you want to go to the very basic science of it, it's how do we turn mostly carbon into gold? And they're quite different. So carbon has a mass of 12 grams per mole. It's atomic number 6 in the periodic table. Gold has a mass of 197 grams per mole and atomic number 79. So they're widely spaced. The densities are hugely different. So I did a bit of a back of the envelope calculation to figure out, how possible would this be? And so I jumped onto Google, as one does, and got a standard hay bale, which I did a little bit of helping out on the farm when I was younger. And I remember them being really, really heavy, but it turns out they're about 25 kilos.
Well, that's reasonably heavy.
Well, it was considering.
Cut yourself some slack, Duncan. Lifting hay bales is good exercise.
I suspect I was about a quarter of my current age as well, so It seemed like a lot at the time anyway. These are just the square ones. These aren't these huge round ones. So the square ones that were, about a metre long, half a metre high, about the same wide. So, pick up a ball. That's, if you do the maths, it works out to be a density for every cubic meter. It's about 125 kilos. Okay, so far so good. If we took that hay bale and did whatever magic is in that woman's spinning wheel and turned it into gold, that meter-long bale of hay would shrink to something that was only 20 centimeters long, has a density of 19 tons per cubic meter. So it's this tiny little thing, still weighing 25 kilos, but now it's pure gold. So your roughly $6 hay bale is now worth on the market at the moment about $2 million. So, you know, you can see why you'd want to do this. But if you were weaving hay into gold, you're going to get some very, very fine gold threads.
Although maybe that's what happened in the story. When you were spinning it, maybe you came up with some kind of golden thread at the end of it.
Yeah. Well, so there is this sort of difference between gold looking and gold. You know, if you really get down to the science of it, what you're talking about is fusion. It's making heavier atoms out of lighter ones.
Yes.
That's what the sun does all the time, hydrogen into helium, you know, and that's doubling the mass of hydrogen. And so you're going from atomic number 6 with carbon to atomic number 79. That sounds pretty, you know, maybe not easy, but achievable. The problem is there's a crossover point in fusion, and that's iron, which is number 26. So remember, gold is 79, carbon is 6. 26 is a crossover. If you're trying to make something by fusion and it's iron size or less, then you actually get energy out. And that's why when the sun combines hydrogen to helium, you get this energy out, bright, sunny, beautiful days. If you're making something heavier than iron, and gold is a lot heavier than iron, 79 instead of 26, then it costs energy.
Really?
So,
I didn't know that, Duncan. I always assumed all fusion would lead to some release of energy, regardless
the
of
other
how big
end.
the atom would be. So when you... Okay, let's go back to gold at 79 on the periodic table. Right. Now, where does gold come out of stars?
Well, this is exactly it. So it doesn't come out of your normal star like our sun, because it doesn't release energy to make gold. You have to put a lot of energy in. So it comes out of things like the Big Bang or a supernova. You know, when there's just so much energy around, you can actually get these heavier elements. It could also be a decomposition product from an even heavier thing that breaks down. So when you're, you know, much heavier than iron, instead of joining together, you're more likely to fall apart.
Does that work with fission when atoms break up?
Yeah.
And that releases a lot of energy. Is all fission down to iron? Does that release energy?
Down to iron, it releases energy when they break apart. I mean, that depends on some nuances of exactly what's breaking apart to make what. But yes, generally speaking, rule of thumb.
And if it's smaller than iron, if it has a lower atomic mass, it's lower on the periodic table than iron, what happens? Do you need to put energy in for fission? You
have to put energy in to make it break apart, yes.
Okay.
And we do that. We've got that in particle accelerators. We can break apart all sorts of things by hitting them hard enough. A lot of my research is on that. We break neutrons off things by hitting atoms really, really hard. So it's possible.
Why is it this mark in the sand, in the cosmic periodic sand, between iron and things that are more massive and less massive in terms of atoms, that it goes from, with fusion you release energy when you fuse things smaller than iron, but you have to put energy in, and vice versa for fission. What's going on there?
Yeah, I've really got two answers for you. The first one is the easy one. It's outside my pay grade. That's what physicists do.
I was expecting
the second
that
one is
Duncan.
it is about the stability of the neutrons and protons in the nucleus. So they're packed in really tight there, and it's a fine balance between the protons that are trying to get away from each other and the neutrons that hold them together like glue, and it's all very messy. And then I refer you back to the physicists again.
Gold, however, would come out of, say, a supernova, a massive stellar explosion? Something
like that, yeah. The beautiful thing about gold, and the reason, one of the reasons we prize it so highly is that it's extremely non-reactive. So you can put it in acid. You can, there are very few ways to make it tarnish. There are very few ways to make it disappear, which is why gold is one of those minerals that you'll find in a stream bed by just shuffling and finding a stone in there. But it also makes excellent jewelry, of course, because it doesn't tarnish. And if it's there, it just doesn't go away. That's great. It has a lot of other really special properties as well. I mean, just as well as being pretty, it's also very useful. It can be beaten down into really thin sheets so that you can use it to coat whole roofs of buildings.
Yes. How thin can gold leaf be? A layer of one atoms, a single layer of atoms, or more than that?
Well, now we're using modern science. You can beat it down to sort of microns in thickness just by getting gold and hitting it with a hammer enough times. But when we're trying to make really thin gold layers now, we can put them down actually one atom at a time and get a single atom thick layer. I do quite a bunch of research with 10 nanometer thick gold films, and at 10 nanometers thick, they look like gold. It's really quite an unusual thing.
And gold can be spread really thinly, but what about, can it stretch? Can you stretch it to make a thread?
You can, of course. I mean, that's one of the characteristics of all metals. It's not a very strong metal, so you'd be likely to break your thread. So you could be weaving this thread of gold, but as thin as it is, it's probably falling apart all over the place. I wouldn't weave cloth out of gold. Partly because it's not a very strong thread, and partly because it would be incredibly heavy. It's very dense.
If we go back to
gold,
carry on, Duncan.
All the gold in the world that has ever existed above ground is about 200,000 tons, and if we put it all into a single cube of metal, it would only be 20 meters or to a side. Right? That's how dense gold is. So it's an incredibly, all these movies where you see somebody running off with a suitcase full of gold bars. No, they're not. They're not?
Really?
No, they're not. They can't.
That gold case gag from 30 Rock probably wasn't gold anyway. It was probably iron.
Probably not, yeah.
Now, so you mentioned earlier that gold, is it possible that gold was created by the Big Bang itself? I thought we didn't have atoms until quite a bit, a few thousand years after the Big Bang.
Well, the effects of the Big Bang, let's say, and again, I'm going to refer you to the precise chronology. That's a physicist's problem. We're all still, to some extent, experiencing the effects of the Big Bang even now. But a lot of the nucleosynthesis happened, if not instantly at the beginning of the Big Bang, but shortly after. But don't ask me for timing.
Yeah, no, that's fine. But going back to Rumpelstiltskin and splitting the gold into thread, I mean, it's just like, that's the stumbling block, is the amount of energy that would be needed to convert carbon to gold. And you would have to put in huge amounts of energy, wouldn't you?
Yeah, no, I mean, we're talking more than the sun kind of energy. So you might have turned your hay into gold, but you may have turned the building into ash at the same time.
Well, not to mention the entire planet.
Yes, exactly. It would be quite impressive, let's just say. So a lot of the times, you say we've had a turn away from science fiction back into the past with fairy tales, but science fiction is just things that we think we might be able to do and haven't done yet. This story actually, as I say, it's an old story. The version we know comes from the Grimm brothers, the Grimm's fairy tales, and that's 1812. But the story itself is way, way older than that. And by tracing the language back, I found variations of the story for 4,000 years. So in a way, this is science fiction. It's just the science fiction of 4,000 years ago that we still haven't delivered on the promise of.
Our fascination with turning something that is commonplace and relatively cheap into something that's extremely valuable goes back for ages. But it's funny that in the end, we were kind of right. You can change matter from one form you can change an element from one form to another. It just takes a huge amount of energy to do so.
Yes. Enough energy, anything's possible. Almost.
Unless, of course, it just decays naturally. in which case uranium, for example, as it decays, it breaks down into, is it lead?
It has a whole bunch of things it breaks down to on the way. So depending on the pathway, lead might be one of the descendants of it, but there's a whole range of different things, and some of them are actually quite useful.
So it seems to me that in terms of one answer to the question, can Rumpelstiltskin turn straw into gold? Well, yes, of course you can turn carbon into gold, but there is another thing that I think about, and that is they kind of missed the point. With straw being carbon, they could have turned it into a diamond.
Well, of course, we didn't understand that it was more or less the same thing at that point. Funnily enough, that would also take quite a considerable amount of energy. Not as much as transmutation into gold, but still a massive amount of energy, temperature, and pressure to do. In fact, diamonds aren't even stable at room temperature and pressure. If you've got a diamond ring, it's right now slowly decomposing into graphite.
Is it? Really? So you spend a whole lot of money on a diamond ring, and if you just keep it, it ends up being just a hunk of charcoal, sort of.
Yeah. I mean, it might take a very long time to do that. So I don't think. I mean,
how long is a long time?
It's going to outlast anybody's marriage. We're talking. It's something that's.
So diamonds are not
forever. Diamonds are not forever.
But they'll last, your average marriage? I mean, how many marriages could you get through? Say we could live forever, How long would it take for that diamond to turn into graphite?
That's a really interesting question.
I know. But you got to expect me to ask a question like that. Now that I've discovered that diamonds decompose into graphite.
Yeah, it's. I will try and work that out for you and let you know on a future occasion.
Yes, that'll be fine.
It's an excellent. What it is an excellent subject for me to bring up in a lecture and let the students try and figure it out. So
I'm going to throw one last question to you, Duncan, without warning. And are most of the diamonds that we find on Earth, were they formed here on Earth? Is there sufficient pressure underground, because I'm assuming this all happens below ground level, to turn carbon to diamonds on planet Earth?
Yes.
There is?
Yes, yeah. Although it's an interesting theory that actually the centre of Jupiter might be one giant diamond, because it's a carbon-rich atmosphere for Jupiter, a high pressure and temperature. And if we've got a Jupiter-sized diamond out there, it's going to put a real damper on the value of your diamond ring.
Mind you, we've just got to get to it and extract it. That might be quite tricky.
It's another challenge. They're all just challenges.
Thanks for listening to this episode of Sci-Fi Sci-Fact with me, Brian Crump. And thanks to our brilliant friends at the MacDiarmid Institute. Sci-Fi Sci-Fact is available on the RNZ website, Apple Podcasts, Spotify, iHeartRadio, or anywhere you get your podcasts from. There are plenty of other RNZ podcasts to listen out for too, like the award-winning Black Sheep. And you can catch more of me every weeknight on RNZ National.